Hi, in this video I'm going to introduce the concept of subspaces. Now we've already dealt with vector spaces in a previous video, and a subspace is a non-empty subset of a vector space. So if W is a non-empty subset of a vector space V, and W satisfies this condition. So if U and W, so little u and little w are any two elements in our subset W, and alpha is a member of a field, and remember, for now, just consider that as being a scalar, a real number scalar. So one vector plus a scalar multiple of our second vector is also in W. Now, if that's the case, then for any two vectors or objects in W, then we say this is a subspace. So, for example, the set of all lines in R2 is a subspace of R2. Okay. Now, knowing whether a set is a subspace is useful since it shares the same properties. So, for example, any results we proved for the vector space also applies for a subspace. So here's an example. So here we got a set U, which is in R3. So we've got a 3-element vector, and U is a set of all vectors which have an x component, a y component, and the third z component, say, is equal to 5. Okay, so let's show that this is a subspace. So we need to take any two vectors in U, so let's call them little u, which is u1, u2, and it has to be 5 in order to satisfy the condition to be a member of U, and do similar for V, and take a scalar which is a real number. Now if we apply the subspace condition, which is u plus alpha v, so we have the vector u plus alpha times the vector v, and if we add them together we get u1 plus alpha v1, u2 plus alpha v2, and 5. Now what we're going to do is check that this vector here is also a member of U. So u1 is a real number, alpha and v1 are also real numbers, so that first number is a real number, and so is the second element, and of course the third element is 5, so that is also in U. So therefore we can say that U is the subspace of the vector space R3. Okay, let's have another look at an example. So this is the set V, and it's also in R3. So V is categorized by having an x component, a y component, and the z component is whatever the x multiplied by the y is. So again, let's choose two vectors from V. So here we've got the vector u. So notice that this y component here is simply the the z component is the x multiplied by the y, and similar for V. So if we apply the subspace condition, so this is our vector u plus alpha times our vector v, and if we add these together, this is what we get. Now the defining characteristic to be a member of V was that your third element is equal to the product of the first two elements. Well, here we can see it's clearly not the case. So since that third element is not equal to the product of the first two elements, then the subspace condition isn't satisfied. So u plus alpha v is not in V, so we say that V is not a subspace of R3. Now, to show that something is a subspace, now we could do it like this, or we just need to show one counterexample. So I picked two vectors here. Okay, so if my x is 1, my y is 1, my z component must also be 1. And let's pick x as 2, y is 2, and my z component is 4. So both of these are in V. If I add them together, I get 335, which is not equal. In order to be in V, that third element should have been 9. Okay, so here we've shown any counterexample to show that something isn't a subspace.